Hello everyone, this is Achinta Medi. So in this video, I'll discuss about chemical kinetics, and this will be the first part. Rate of reaction in terms of reactant. It will be minus dC by dt, which is C2 minus C1, T2 minus T1, where C2 is less than C1 and T2 is greater than T1. Rate in terms of product. So it will be like this. C2 is greater than C1 and T2 is greater than T1. That's why it will be positive. Here there is a positive sign. So positive sign defines that the amount of product is increasing, and the negative sign defines that amount of reactant amount is decreasing. So general equation of rate law expression. So first of all, we have to consider a reaction. Suppose so this small a, small b, small d are the coefficient, and a and b are the reactant, and c and d are the product. So if we write rate law expression, then it will be like this. So for reactant, the coefficient will be like, we can write like this, as this is the reactant, so there will be a negative sign in front of this, and a we can write like this, is equal to b is same, like we have to write this, and as c is the product, so there will be positive sign, and c will be as a reciprocal, plus d let's take an example. N2 plus thrice H2 is equal to twice ammonia. So if we write the general equation of rate law expression of this reaction, then it will be like this. There will be 1, as there is a 1 reciprocal here, so we can write like this, and next is equal to minus, as this is the reactant, next this is the product, that's why we will write positive sign, and 2 will be reciprocal, and so this is an example to understand rate equation of rate law, general equation of rate law expression. This is the problem. You can see this in a reaction. This is the reaction. This is the reaction. So the rate can be expressed as, these are the 1, 2, 3 some points. You can see that. So these are the condition. We can express the rate. So, and we have to solve that the K1, K2 and K3 are how they are related to each other. Okay, there is K1, K2, K3. So we have to show how K1, K2 and K3 are related through this condition with this equation. But that means this is the reaction. So we have to solve this. So first of all, we have to write the general equation of rate law expression of this reaction. So what will be the rate law expression? We can write. So as 2 is the in the reactant side, so we can write minus 2 d N2O5 dt. Next is equal to, as this is the product, so it will be positive 1 by 4 dNO2 plus the dt plus no is equal to, there is 1, that's why we shouldn't write, we can write like this. So, and as we know that the rate expression, we can write what? Rate constant into the concentration of the reactant. So we can write the rate constant and this reactant, concentration of the reactant. We can write the rate expression like this. So this one are is equal to the rate of the reaction. This is the rate of the reaction. At first, minus dN2O5 dt is equal to, we can write 2 will be here, twice K N2O5. Okay, so we can write this 2K as K1 N2O5. Next, we can write this dNO2 dt is equal to, 4 will be there, 4K N2O5, which is equal to K2 N2O5. Okay, next we can write, there is no 1 2 something like that, there is no reciprocal here, so we will write K N2O5, which is equal to K3 N2O5. We are writing this part because this is the condition as given in the question. These are the condition. So we can write this part is equal to this part. Okay. Next, this one is equal to this one. So we write here this one and this one is equal to this one. We can write here. So from this 3 equation, we can conclude that twice K is equal to K1. Okay, twice K is equal to K1. Next, 4K is equal to K2. Next, K is equal to K3. So how they are related? We can write K is equal to K1 by 2 is equal to K2 by 4 and is equal to K3, or twice K1 is equal to K2 is equal to 4K3. So this is the solution. So K1, K2, K3 are related to each other like this. We can evaluate that by from this general equation like liter n minus 1 mole 1 minus n second inverse. So this is the unit of rate constant, and this n are the n is the order of the reaction. So if this is the zero order reaction, zero order reaction then what will be the zero order reaction? Then it will be n, we will put 0 here, so L 0 minus 1, okay, mole 1 minus 0 second inverse. So it will be liter inverse mole second inverse. We can directly say that if this is given, rate constant of something, rate constant of a reaction is given, and there will be a digit, obviously there will be a digit, and the unit will be there. So if you can see that the unit of the rate constant is this, then you can directly say that this reaction is zero order reaction. Okay, so next, for first order reaction, we can put here 1 L 1 minus 1 mole 1 minus 1 second inverse. So it will be, this will be 0, this will be 0, and only second inverse will be there. So if there is a reaction is given and rate constant is given, and if you can see that the unit of the rate constant, then you can directly say that that reaction is first order reaction. Okay, next, second order reaction. Next, L, for second order reaction n will be 2, so mole 1 minus 2 second inverse. Then you can write L mole inverse second inverse. So we can write the unit of second order reaction like this. This will be the unit of rate constant for a second order reaction. Kinetics of zero order reaction. So first of all we have to consider a reactant. Suppose A is the reactant and P is the product. So at time 0, when at the initial state, when time is 0, then concentration of reactant will be A, and there is nothing like product. So concentration of not concentration, mole amount, that means amount is A, and the product of amount of the product is 0. So at the time t, when we consider a time t, at that time some amount of reactant will be converted to product, and some amount of reactant will be present here as a reactant. So let consider X amount of reactant is converted to product. So we have to write here X. X amount of product is converted to reactant to product. So there will be A minus X amount of reactant here. So So if we write the rate of reaction, we know that rate of reaction is directly proportional to reactant, concentration of reactant, and we have to put the order as it is 0, it is 0 order reaction, so we have to put here 0. Okay, so rate of the reaction we can write in terms of reactant and in terms of product. So in terms of reactant it will be minus dA by dt, and in terms of product dP by dt. So as I have already told you that in case of reactant, the amount of reactant is decreasing. That's why we write negative sign here, and there will be positive because product is forming. That means amount of product is increasing. That's why there is a positive sign here. So we can write here K, as we have to remove this proportionation sign, so we have to write a constant, that is rate constant. So for 0 order reaction, rate constant will be K naught. We will write K naught, and this will be here. So we know that this part A to the power 0 is equal to 1. So we can write K naught 1. K naught 1. So in case of reactant, it will be K naught, and when t at the time t, when t is equal to t, time is equal to t, that means we can write in here we can write d dt, we can put this one a minus x. A minus x is equal to K naught a to the power 0. So a to the power 0 is 1, that's why we will write K naught here, K naught. So we can write d a dt minus minus plus dx by dt. So K naught. So as we know that if we differentiate a constant part, then it will be is equal to 0. So we will not write this one, so we will write dx by dt is equal to K naught. Okay, so we can write like this, K naught dt. So if we integrate this one, dx is equal to K naught dt like this. So it will be x K naught t plus, there will be a constant, integration constant. C is the integration constant. So when t is equal to 0, that means this part will be 0. So and as we know that when t is equal to 0, the product is, that means x part is 0. There will be a amount of reactant, but product is 0. So this is the product, amount of product which is converting from reactant to product. So so we have to write at the initial state, when t is equal to 0, x will be 0. So this one 0, this one is 0, this one is 0. So we can write c is equal to 0. Okay, so as c is equal to 0, at the last step we can write the rate law expression. of zero order reaction is this part is 0, so we can write x is equal to k naught t. Half-life of zero order reaction, and we can evaluate like this: when t is half, and then x will be a by 2. So a is the mole of reactant. When a is the reactant, p is the product. At t is equal to 0, a is here, product is 0. When t is t, then it will be t minus a minus x, and it will be the x. So this x is this one, and this a is this. So when t is half, then this will be a by 2, and of course it will also be a by 2. So when t is t half, x will be is equal to a by 2. So if we put in this equation, then how it will look like: a by 2 k naught k half. So we can write t half is equal to, k will be here, a twice k naught. Okay. Again, if we plot CT, that means the concentration versus time, but in case of product, what will be the graph? In case of product, A is the reactant, product is P. At t is equal to 0 time, C naught, product will be C dash, and when t is equal to t, CT dash. So in case of C naught and CT, what will be the graph? So in case of product, we can write dx by dt is equal to k. So here there is a positive sign, because of the product is increasing, amount of product is increasing. So this is the reaction expression. Now we can write dx is equal to k dt. So if we integrate this, this will be the dx k dt, time will be 0 to t, and this interval will be c naught dash to ct dash, so ct dash minus c naught dash is equal to kt. So we can write ct dash is equal to c naught dash plus kt. Here y is equal to mx plus c. So c is the c naught, m is k. So the graph will be like this: ct is here and t is here. So k is positive, so graph will be like this. Slope m is equal to k, and this intercept is c naught dash. So graph will be like this. You can see that the reaction, this is the reaction: 2N2O5, 4NO2 plus O2. These are the product, and the forming NO2 at the rate of 0.0072 mole per liter per second. at at the same time. So we are going to evaluate what is the rate of the change of O2 and what is the rate of change of N2O5 and what is the rate of the reaction. So first of all, we have to write the rate law expression of this reaction. So as this is the reactant, so we can write 1 by 4 NO2 dt is equal to dt. So as this is given, N2O of which rate is this one. So we can write NO2 N2O dt is equal to 0.0072 mole per liter per second. So first of all, we have to evaluate the rate of change of O2. So a rate of change of O2, what will be is equal to, so we have to compare this one and this one. Okay, so we are going to evaluate this one dO2 by d2 dt. That means rate of change. Rate of change means d by dt. So we are evaluating this. So if we compare this one, so 1 by 4 and this is given dNO2 by dt is equal to this one. So we can write this. So it will be 0.0018 mole per liter per second. Again, in case of N2O5 in case of dN2O5 dt is equal to, then we are comparing this one and this one. Okay, so as this is minus, we have to write this minus. 2 will be here, 2 for dNO2 dt. So this will like this, half 0.0072, and this is minus 0.0036 mole per liter per second. Again, if we are going to evaluate the rate of reaction, then what will be the rate of reaction? So as this is given, a rate of formation of NO2. So rate of the reaction will be reaction will be 1 by 4 from this. We are calculating from this 1 by 4, as this is, we can write N2O5, as we know that the rate of a reaction, we can write this constant, rate constant, and the concentration of the reactant. So this is equal to this one. So we can calculate the rate of the reaction from this. So 1 by 4 and this part is equal to 0.0072 is equal to 0.0018 mole per liter per second. Problem, and this problem is At some temperature, the rate constant for the decomposition of Hi on a gold surface is 0.08 molarity second inverse. So this is the reaction. So they are questioning that what is the order of reaction. So first of all we will find what is the order of reaction. Then how long will it take for the concentration of Hi to drop from 1.50 molarity to 0.30 molarity. So first of all, in case of order, as I have already told you that by, if you see that the unit of the rate constant, this is the rate constant is given. So rate constant is molarity second inverse. So molarity means mole liter inverse second inverse. So as the general equation, I have already told you that liter n minus 1 mole 1 minus n second inverse. So think about this, what will be the value of n? By putting that value we will get this unit. What will be the value of n? So to be mole, so it will have to be 0, because as 1 minus 0 is 1, so m mole will have the power 1, there is 1. And in case of liter, if we put 0 here, then only 0 minus 1 is minus 1, that means L minus 1, we will get this. So by putting n is equal to 0, then only we will find this value is equal to mole liter inverse second inverse. So we can conclude that n is equal to 0, so order is 0. So next part is when the concentration of Hi drop from this to this. So we have to write dx by dt is equal to k. This is the general expression. So this is the concentration of the reactant. So you can see that there is a coefficient of Hi. So we have to write this coefficient like this. Okay, so rate constant is given. This is the rate constant 0.08. Next to t, we are going to evaluate how long it take. So we will find dt and dx will be this and this. So 1.50 minus this one. So we can take this from to this one. You can take here 1.20 is equal to dt. Then we can find dt, it will be 7.5 second. So 7.5 second will be taken for this reaction for the concentration of Hi to drop from 1.5 molarity to 0.30 molarity. Thank you everyone for watching this video. If you like it, please subscribe my channel and share with your friends.